Hello and welcome back to our calculus series where we learn calculus without knowing calculus. Lesson number 5. We are going to learn how calculus measures change relative to something you choose. You choose because you want an answer to a question that I'm trying to measure a change with respect to something. Before we dive into today's lesson, let's do a quick recap where we left off. In the previous chapter, we established that a physical system can be described as a mathematical model, a function, or an equation, and that mathematical model can be used to measure change or predictions. And we chose a model where we said that we took the social media video as an example, that it depends on number of shares, the number of views depend on number of shares, comments, subscribers. Measuring change with respect to what? So choosing with respect to depends on the question that you're trying to answer. Let's look at an example. We have three people. Each individual is asking a different question. The first person, that person is interested in knowing that how the views change every day. Notice every day. For this person, time is the reference. Second person is asking question, how do views change if number of subscribers change? Notice this for this person, the subscribers is the reference. The third person is asking the question, how do the number of views change if the number of shares change? Notice for this person, number of shares is the reference. But there's one thing that is common in all three questions. All three people are interested in knowing the change in number of views, meaning DV. The only thing that has changed is their reference. For the first person who is interested in knowing changing in the views every day, that person is interested in knowing dv with respect to dt. Second person who is interested in understanding the change with respect to subscribers, that person is interested in knowing dv du. Third person who is interested in knowing the change in the views with respect to shares, that person is interested in knowing dv ds. So you can see that all three are asking question. All three are interested in knowing the number of change in the views, but with respect to a different reference. With respect to a reference, that means a cause. So a cause causes a change. We learned that in the previous chapters. So we pick a cause which has a relation with the change, meaning in some way the cause is related to the effect. In calculus, you represent it by y is equal fx, or if you read it like a sentence, y is related to fx. Let's take a look at an example. Let's say here we have a wall. Wall's height is h, and this is our floor. We place a ladder against this wall. Let's represent the position of ladder's base from the wall by x. And the height that we can reach with this ladder against the wall, we represent it by y. Let's ask ourselves a question. If I change the ladder's position, if I move ladder left or right, is that going to change wall's height? And the answer is no. Wall's height has no dependency, or wall's height is not related to position of the ladder. That means h has no dependency on x. So if you will choose height as your reference, or if you're trying to measure h, that will be a wrong reference you have chosen. Now ask the question, if I move the ladder left or right, is it going to change the height that I can reach on the wall? The answer is absolutely. Let's visually, if you look at it, if I move this ladder to the right, that means now I can only reach smaller height. Whereas if I move the ladder left, I can move greater height. So that means the height that I can achieve, the height that against the wall that I can reach, it varies by varying x. That means y does have a correlation with x. If you choose a reference that has no relation, that means we have chosen a wrong reference. Let's talk about the area. Let's look at a square. How do we measure area of a square? Area of a square is you square the side of this square. So let's say that A is the length of this square. So if we represent area by y, the area becomes a square. Now, if you want to know how the area will change if the side of this square is increased, let's say that you want to increase the side of the square by b. Now, the new square, you draw it like this. So what is the area of the square? The new square. That means if the side has become a plus b, the new area is a plus b square. If you look, this is the same, this looks like an algebra equation that you have studied in high school. You can expand it, that this new area becomes a square 2ab plus b square. So visually, this is how this is represented. So this part is your AB, so 2 of 2AB plus B square. And now if you have to answer the question that how much area changed, it's a simple math. You subtract the new area from the old one, which was a square. You subtract 2, and what are we left with? That change in the area is 2ab plus b square. That is how you measure the change in area when you change the side, the length of the side of the square. Now let's look at how this project to calculus. We said that area of the square was a square. Now there we represented this with a square. You can actually plot the same equation and it will look like this. You can see that it's the same model. One is representing the area, a square. The second one is representing a curve. Now, if I want to understand that how, so on this axis we have x, and on this axis we have y. So for a given x, there is a value of y. So if you want to understand that how y changes with x, so now we represent a, now we're going to replace a with x. So y is equal x squared. Let's change the value of x by a small amount, dx. Now compare this with what we had before. It's no different than the algebra equation that we used when we computed the area of the square when we changed the length of the side. You can use your knowledge of algebra to expand it. The only difference is b has been replaced with dx. Now if you want to understand that how much y changed, you apply the same concept that you subtract the new value of y from x, the new value of y from the old value of y, and the old value of y was x squared. That means dy is what? It is 2x dx plus dx squared. You measure the change. So all the concepts of algebra that you learned in your previous classes in high school, now they are applying to calculus as well, that you didn't have to learn something new. You already knew it. The only thing that changed is the terminology. Let's expand this a little bit. Let's go back to our square, where we said a is the original length of the side. We increased it to a plus b. So this area of this rectangle. So we said y is equal to a plus b square, and we figured out that the change in the area was 2ab plus b square. Let's make this change in the side, the length of the side, very small. Let's look at this visually. So original is a, and this time we are only going to move it very little. It is the same concept that you are changing the length of the side, but this time we are saying it is very, very little. So look at this b square. As you will keep reducing the change in the side length, that is b, eventually you will come to the point that where this tiny square will become very, very small, and it will become insignificant. Now let's extend this to our calculus equation, y equal x squared, where we establish that if we change x by dx, the new value of x is 2x dx plus dx squared, and the change in value of y is 2x dx plus dx squared. Now we have both equations side by side. The algebra equation, which was representing a square, the calculus equation, the same equation, it is representing a curve. As we saw that if we make this b in the square very tiny, eventually b squared becomes very, very small. It reduces to the point where it does not have a significant impact on the change in the area. If we project the same idea on the curve, we can say that if the dx, that the change in the value of x, is made very small, so if you think about that, so which part of this change in the value of y becomes so small that its impact on the overall change in dy is not significant? And the answer is dx squared. And if you choose the value of dx so small, let's look at the numbers. Let's say dx is 0.1. So in this case, dx squared is what? 0.01. And if I say that dx is 0.0001, now you can starting to see that this dx squared is the impact of the value of dx squared is such that it does not have a significant impact on the change in y. So it reaches to the point where you will be able to say that it is insignificant, that dy is 2x dx. And if you rearrange this equation like you have done in algebra, this can be written as dy dx is equal to 2x. And that is how you compute. And that is how we measure the change in dy with respect to x. As we established that it's not always dy dx. It depends on what the notation you are choosing and what reference you have chosen. But this is the how you measure change with respect to something that answers your question. Now, let's bring it all together. What we studied, that first we define a system, what we are trying to study. Then we have a question that we are trying to answer, and we establish what is the cause that is going to cause this change. And then we measure the change with respect to the cause that we have chosen. And that was what this lesson is all about, that how do we measure change with respect to something that we choose, something that answers our question. So now that we have established that how we measure change, and we said that to measure the behavior of a model, the change should be tiny. But the question is, do you believe what I say, or do you believe what the textbook says, or would you like to observe it yourself and to really study the impact of that, why a tiny value matters? So in the next chapter, we're going to try to write some Python code to illustrate this concept and establish that to study the behavior of a model, study the behavior of a complex system, that we have to study with tiny changes. It is no different than studying somebody's life. You don't get to know somebody's life by moving from childhood to the old age. That does not give you the real picture of the life. You, the more, if you study a person's life on a day-to-day basis, that is more interesting because it gives you the true nature of a person's personality. Same way, a model defines the personality of a physical system. You study the changes by measuring with small changes. I hope I was able to explain how you measure changes. If you like our video, do subscribe, like, visit our website to find more information. Till next lesson, take care. Goodbye.